In a universe that shines with innumerable stars, born from countless more stars that have come and gone before them, rages the life-giving fire of our sun.
The sun is the king of the solar system. It has essentially all the mass and all the energy.
Familiar and yet unknown.
Even though we've looked at it for a really long time, the sun is still full of mysteries. Why is it hotter in its atmosphere than on its surface? What drives the solar wind?
Only now, we take our first steps closer to understanding our star.
It is the first time that we're actually going in to touch the sun.
And it's already really started to truly transform our understanding for how the sun works.
Uncovering the secret power of all stars.
As you can imagine, when you have a huge blob of flaming gas, the core is usually the hottest, and it is where the magic is happening.
Perhaps even finding clues to the stars that came before it.
If we understand where the sun comes from, we can understand a little bit more about where life has come from.
And ultimately, its fate.
It has about another 4.6 billion years of nuclear fusion left, and then it will start to change. It will start to evolve.
We really need to understand what will happen to our own sun, because that will impact Earth.
The sun is just one among hundreds of billions of stars in a galaxy among trillions. We live in the age of stars, right now on Nova. $93 million miles from Earth, our nearest star, the sun. A permanent fixture for life on our planet.
Humans have always been fascinated by the sun, I think because it is so constant compared to our daily life.
It's been rising and setting since the day that we were born. We keep time by it. We keep our calendars by it. Without it, life wouldn't be possible here on Earth.
The sun is just one of more than 1 billion trillion stars in the universe. Why is it around our star that life has emerged?
We want to know, where do we come from? And what are our cosmic origins?
If we understand where the sun comes from, we can understand a little bit more about where life has come from.
But our star is an enigma.
The sun is still full of mysteries. Why is it hotter in its atmosphere than on its surface? What drives the solar wind?
We've spent millennia studying from afar, but only now are we getting close enough to truly reveal its secrets.
The sun's not a very nice environment. It's not easy to get up close to the sun.
It's an enormous ball of hydrogen, and it's putting out a tremendous amount of energy.
Its surface is a bubbling cauldron of 10,000-degree plasma.
We can actually see cells of hot gas rising and falling. It's an incredible imagery.
And then above that, you have this very thin atmosphere that's 1,000,000 degrees. Super hot.
Seeing these images is like revealing something that's been right in front of us, but hidden for so long.
Occasionally, you might see this enormous coronal mass ejection erupting from the star.
We now stand on the threshold of being able to survive a close encounter with a new heat-resistant probe that's giving us an up-close look at our sun for the first time.
Status check. Go Delta. Go PSP. Minus 15.
Launch night, I was sick to my stomach.
5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
There we go.
The Delta IV Heavy is a very slow rocket compared to the other launches I've seen, so I just saw fireballs and was very, very frightened for a while.
25 seconds into flight.
It is quite scary to think about all that power in the rocket underneath that, relatively small spacecraft sitting on top.
Pressures continue to look good on all 3 boosters.
Then realizing that this was all okay as it slowly made its way up into the sky.
Now 50 seconds into flight. And we have jettison of both strap-on boosters.
Parker is just an exquisite mission. It will be the closest that our species has thus far come to literally touching the sun itself.
The Parker Solar Probe is traveling to a place that has been completely unexplored up close. Until now.
NASA's Parker Solar Probe. A daring mission to shed light on the mysteries of our closest star.
This is a journey into Never Never Land, you might say.
During its 7-year mission, the Parker Solar Probe will attempt a series of dives towards the surface of the sun. Its goal is to understand how the sun sheds its energy. Orbiting a total of 24 times. Each pass taking it perilously closer. So close, it will enter the sun's atmosphere. Braving temperatures no spacecraft has ever endured. And traveling faster than any other human-made object has before. The mission is still in its early days. But in the coming years, the Parker Solar Probe will help us unlock not only the secrets of our own sun, but all stars, including those that hold the key to the sun's origins and our own.
we can look at the processes, look at what's inside the sun, and understand how it had to become that. What were the generations of stars before that? What was its ancestry?
The sun's story can be traced back to its most distant stellar ancestors, the very first stars in the universe. Almost 100 million years after the Big Bang, the universe is dark and cold. Not a single star shining. But this universe is far from empty. Something is growing in the void, stretching out tendrils.
The early universe was largely hydrogen and helium, and only small amounts of other materials.
None of the elements we see these days, no carbon, oxygen, iron, none of that.
Even though the name, the Cosmic Dark Ages, suggests that there might not have been anything particularly interesting going on, it was really kind of laying the groundwork for the construction of the cosmic web.
The cosmic web is literally the structure of the universe itself.
The cosmic web is unimaginable in scale. Huge clouds of gas are drawn together by the gravity of a mysterious, invisible form of matter called dark matter, creating a great network of filaments. A web the size of the cosmos. The gas in these tendrils is made up of mostly hydrogen and helium. Where these great filaments cross are the places where the first stars will one day be born. The cosmic web has been shaping our universe for 13.8 billion years. And it's still doing so today. But it's only recently that we've actually been able to see it.
The image that we have here is absolutely amazing. It's one of the most fundamental pictures that we can take in our universe. And it's actually a direct image of some of the largest structures that exist, the filaments of the cosmic web. Now, the bright dots that you see over here, they're entire galaxies. Now, if I take those away, what you can see much more clearly is a faint glow of the hydrogen and helium that exists on the tendrils of the cosmic web. And it's on this cosmic web that the story of our sun and the stars in the night sky begins.
As time passes in the early universe, the cosmic web continues to grow. Gas rushing along these great tendrils, traveling down towards the intersections. It is being pulled to these points by gravity. And as more gas joins, this force becomes ever stronger, creating great clouds staggering in size. They grow denser, hotter, as gas is relentlessly added, until at last, the conditions become so extreme that there is a sudden moment of ignition. The birth of the very first star in the universe. Born 17 times hotter than the sun. This star is a blue monster.
The first stars were unlike anything we can see around us today, which is what makes them so incredible.
When the very first stars formed, these stars ended up with giant masses of 500 to 600 times the mass of the sun.
Stars today are perhaps as hot as 100,000 degrees, and these stars were nearly twice as hot as that. And the very hot color tends to also make them look blue.
But this first star is not alone for long. At intersections across the cosmic web, it's soon joined by others. An entire generation of first stars. Lighting up the universe. But this isn't all they do. These stars are also forging new elements, creating the ingredients for all the planets, and ultimately even for life to exist.
The birth of the first stars signaled a complete transformation in the makeup of the universe. Before they existed, all we had was hydrogen and helium, but nuclear fusion completely changed all of that.
The cores of the first stars were so hot, they reached more than 100 million degrees, and that forced hydrogen atoms to change.
Now, under the very high temperatures and pressures that you find in the cores of these stars, they were smashed together, fusing a heavier element, helium.
But the first stars didn't stop there.
After a few million years, the hydrogen completely runs out. So instead, the helium atoms are forced to be smashed together, creating even heavier elements, such as carbon, oxygen, and iron.
The new elements these first stars forged are the elements that seed other types of stars, planets, and even us. In other words, the elements for life. But the era of blue giants can't last.
Fusion at the center of a star eventually ends as it runs out of fuel, so the process can't go on forever.
When fusion stops, you lose that internal pressure which pushes against gravity. You lose a tug of war, and the gravity starts to push down on the star.
You know that saying, live fast, die young? That really applies to stars, right? So the most massive, luminous stars have the shortest lifetimes.
Even though they have much more hydrogen fuel than an ordinary star like our sun, they burn it so quickly that they only live a few million years before they burn out. And a few million years in astronomy time, that's the blink of an eye.
with its fuel spent, fusion reactions stop. And gravity takes over. The core collapses. Gas suddenly falls inwards. And then rebounds in a colossal explosion called a supernova. A shockwave of energy, followed by material hurtling outwards into space.
Supernovae explosions rock the universe. They are amongst the most explosive events that we now know about. Briefly, a single supernova can outshine an entire galaxy.
This was a very important moment in the history of the universe. It allowed the universe to kind of start evolving.
After the first stars exploded, the material that has been forged in their interiors was spewed out into space.
They seeded the universe with these heavy elements and paved the way for subsequent generations of stars.
Generations of stars that we can see in the night sky. The Hubble Space Telescope has been studying them for more than 30 years. Showing us this epic cycle of cosmic death and renewal.
It's not only the first stars which enrich the universe. As you go on for the second, the third, the fourth generation of stars, they're all creating more and more heavy elements which get expelled into the universe.
Hubble reveals to us how stars have evolved. From a primitive universe dominated by blue stars, to our universe today, populated by stars of every color, size, and configuration. Neutron stars violently spinning up to 700 times a second, spitting out jets of radiation. Stars so huge that more than 1 billion suns could fit inside them.
There are many types of stars. Wolf-Rayet stars, red giant stars, white dwarf stars. All of them have their own unique characteristics.
And some that aren't alone. They are kept company by systems of planets, including rocky worlds, built of ingredients like carbon, silicon, and iron.
So stars really are the engines of higher order complexity in the universe, right? They're the factories that make up the heavier elements that are the seeds of things like planets.
Stars have changed the entirety of the universe, filling it with all manner of wondrous celestial objects, and ultimately paving the way for a star that has all the right conditions to make us.
The sun must have relied on many, many generations of previous stars for the material that's there today in our solar system. Probably thousands of other stars that would have had to explode.
"9 billion years after the birth of the first star, the universe has been enriched with dozens of new elements. Here, gravity draws one cloud together, and our own star is born. But not all of the material is used to create the sun. Some remains in orbit. And it's from these leftovers that 8 extraordinary planets form our solar system.
The sun has a very tight relationship with all the planets in the solar system. Not just because of its enormous gravity, but because of the light that it provides.
Some of these worlds seem just too far away from the sun for complex life to take hold. Deprived of light, they may be devoid of any life at all. These are the gas and ice giants. In contrast, others are too close to the sun. They are relentlessly blasted until they become scorched deserts. But there is a sweet spot. Neither too far nor too close to the sun. It's in this place that the chemical legacy of generations of long-gone stars would form something astonishing.
We are on the Earth on kind of this special sweet zone. They call it the Goldilocks zone.
This exciting distance from a star where a planet could conceivably have liquid water on its surface.
Water is the medium that facilitates the biochemical reactions that are responsible for life.
Earth's relationship with the sun is the most important relationship there is.
The sun is constantly reaching out to our planet, something the Parker Solar Probe is helping us understand.
What makes Parker so great is the fact that it has a great set of instruments that work together in order to look in all directions.
So there's this sun-facing part of the probe that peaks above the heat shield and literally looks directly at the sun.
The Parker Solar Probe is spotting holes in the sun's atmosphere. Vents that release a blizzard of charged particles at more than 1 million miles an hour. What we call the solar wind.
We can tell how the energy flows, where the wind is coming off, how much of the wind is coming off.
The solar wind travels billions of miles, bombarding the planets with radiation.
The charged particles in the solar wind can be detrimental to life. On Earth, we're protected by the Earth's magnetic field, which deflects the particles.
So it's kind of like we have our shields up, and our shield is our magnetic field.
Earth has defenses that protect life from our star's violent tendencies. But the sun also provides something essential to our planet.
At the core of it, the sun is forging hydrogen into helium, which is what is releasing the energy that we get here on Earth.
The photons, these packets of energy, when they are formed, they don't go straight from the center rushing through to the surface. They go through a very bumpy ride. They get tossed from one atom to the other. They get absorbed and spit out, absorbed and spit out.
So it takes a really convoluted path out of that sun, and that can take millions of years.
Once these photons arrive at the surface, they're liberated as sunshine. The light races across the solar system. Unobstructed, it flashes past the planets at 180,000 miles per second.
If you could take all the energy that humans are producing and store it in batteries, the entire civilization, for 50,000 years, you could make the sun shine for 1 second.
It takes just over 8 minutes for the sun's light to reach Earth.
That stream of light is like an umbilical cord of energy coming down to us here on the Earth. And it's been pretty much constant and unbroken for nearly 5 billion years. And it's this combination of the stability of light, stability of energy, over billions of years that means complex life that we see around us here on the Earth has been able to form and has been able to thrive.
We don't know exactly how life emerges on early Earth. But what we do know is that primitive cells living in the ocean begin to use the sun's energy to power life-giving chemical reactions. These cells are the bridge between sun and Earth. Tiny machines that harness the power of our star. The cells use sunlight to turn carbon dioxide and water into food in the form of sugar. This process, photosynthesis, is a direct use of the sun's power. It has driven the evolution of complexity on Earth. From primitive bacteria to plants and trees. An unbroken line of living things, all connected to the power source in the sky.
Everything from the little blade of grass to the biggest oak tree, they use the sunlight to photosynthesize and produce the energy that we later consume to sustain ourselves. So in a way, we have been feeding on starlight.
Trillions of stars have existed since the universe began. But ours is the only one we know of that has nurtured that wonderful thing, life. Not only nourished by the sun's light, but also granted protection and the time to grow and change, eventually creating complex life.
The sun is connected to our very existence. It provides the light and the energy that's necessary to sustain life.
There would absolutely be no life on Earth if there was no sun.
The sun is a creator, bringing together atoms forged in generations of ancient stars. To create us. Beings capable of exploring the cosmos. And uncovering our own stellar ancestry.
It's a wonderful thing how we share this intimate connection with stars because they are part of our cosmic heritage. We are the children of these stars.
There are up to 400 billion stars in our galaxy. And there are 2 trillion galaxies in our universe. But it wasn't always that way. We are living in the age of stars. An era of light in the universe.
Stars have always been important to us. They have helped us navigate the land and the open seas for millennia.
If you just think back at the countless sonnets and poems and songs, there is always some kind of celestial connection.
One of the reasons why looking up into the stars is so significant is because we realize that others are doing the same exact thing. And so in a very real way, we feel connected to people, both past and present.
From our fleeting human perspective, the stars seem everlasting. A constant in our night sky. But seen across the age of the universe, the picture changes. Because this era cannot last. The stars will eventually wane. And as they go, they once again change the character of the universe. Their cores, where fusion once raged, cool. and eventually solidify, locking precious elements away beneath the surface and starving the universe of the material needed to make new stars and planets.
The chance that a star is going to be born nowadays is much, much lower than it was billions of years in the past.
Just as there was a very first star in the universe, there will come a time when the era of stars will come to an end.
The age of stars is not as enduring as it might seem.
I have here a timeline of the universe, and I'm here at the start when the universe formed 13.8 billion years ago during the Big Bang. Now, it took a while for the first stars to form, in fact, a few 100 million years. Let's call that 400 million years. So on my scale, stars start to form here, and those stars carried on forming, and then we reached this point here, 4 billion years since the Big Bang, and a time when the most stars are forming in the universe. Our sun, though, didn't form until 9 billion years had passed, and that's my marker here. And then we move forward again, and we get to this point here, which is the present day, 13.8 billion years since the formation of the universe. Now, our sun won't live forever, and in fact, it will start to die and end its life in around 5 billion years' time. But the sun will be outlived by the least massive stars in the universe. They have lifetimes of a few 100 billion years, and that's about 200 meters on my scale. But even when those stars die, that doesn't mark the end of the universe. The universe could live forever, with the timeline stretching far off into the distance. And that means that the age of starlight that I've mapped out here is like the blink of an eye to the universe. It's the age of darkness that goes on and on and on.
Stars won't suddenly disappear, of course. They'll be here for hundreds of billions, perhaps even trillions of years to come. But slowly, over time, the universe will become darker, emptier. As it expands, the distances between these little islands of light become greater and greater, until one day, only one type of star will remain. Red dwarfs. The longest lived of all stars in the universe. TRAPPIST-1 is one of these near immortals. This ancient star is likely more than 7 billion years old, almost twice as old as our sun. But TRAPPIST is tiny, a similar size to Jupiter. And less than 1% as bright as our sun. It is a cool star, slow burning. And that is the secret of its longevity.
The lifetime of a star is determined by its reservoir of hydrogen, of nuclear fuel. As long as it has something to burn, it will continue to survive. But paradoxically, the stars with the least amount of hydrogen live the longest. And that's because They are miserly. They spend their fuel so slowly.
And so it's those smaller, more quiescent, less energetic stars that ultimately become the greatest historians of the universe.
It's especially exciting because this particular star is going to continue fusing hydrogen into helium in its core and continue shining for potentially hundreds of billions of years.
Like the sun, TRAPPIST has its own planets. Seven worlds, each roughly the size of Earth. Some may have atmospheres and even oceans. But there, the similarities end. Because these are strange worlds. Just as one side of the moon always faces Earth, these planets may be what we call tidally locked in their orbits. One side permanently looking towards the red dwarf TRAPPIST-1, soaking up what light and warmth it can from the faint star. The other side permanently frozen, facing the cold void of space. These planets are witnesses to much of the life of the universe. They were born near the start, and they will survive to near the end of the age of stars. They will see entire galaxies merge and eventually begin to fade in their night skies. They watch as countless stars come and go, bearing witness to the time, about 5 billion years from now, when a distant star begins to fade and vanishes from the night sky. As our sun finally exhausts its fuel and disappears forever.
Ultimately, once the fusion process is over in the sun, it will begin to expand into what astronomers call a red giant, and the outer envelope of the sun will expand.
It's going to gulp up some of the planets around it. Unfortunately, Earth is one of them.
And as the sun dies, so too will many others like it. The age of stellar creation in the universe is waning.
The universe is like a slow-motion fireworks show, and we're kind of watching the end of it.
It's unlikely that TRAPPIST-1 will be the very last star in the universe. But we do believe the last star will be a red dwarf. As its fuel runs out, fusion comes to an end. The last star slowly cools and fades away. with its passing, the universe becomes cold and dark. Without light, and most likely, without life.
When the last red dwarf stars die out, that will be the end of stars in the universe. And it was starlight that really lit up its story.
A universe without light may be unfathomable to us humans. Stars made us and our planet. They defined the universe as we know it today.
It was like a gift given to humanity, that it took a cosmos to make you.
A cosmos eventually defined more by darkness than by light. But for now, we exist and learn and grow as tiny sparks within the bright and light-filled childhood of our universe. We live in the age of stars.
Discover the science behind the news with the Nova Now podcast. Listen at pbs.org/Nova Now podcast or wherever you find your favorite podcasts.
To order this program on DVD, visit Shop PBS or call 1-800-PLAY-PBS. Episodes of Nova are available with Passport. Nova is also available on Amazon Prime Video.